Hello everyone, this video will show how to evaluate logarithmic expressions. Now let's go over this first example. So we are given lne. To determine the value for this expression here, we're going to equal this whole expression to a variable. Let's say we have x. From here, we can go ahead and change this given expression that we have right here into its equivalent exponential form. Now, please remember that if we have ln, the invisible base of this logarithmic expression is the Euler's number letter e. So that means there is an invisible e base right here. So from here, we can go ahead and change this to its exponential form. That would be e, that's the invisible e right here, raised to the power x is equal to e. So I'm going to go ahead and write that expression up here. Now, please remember that the invisible exponent of e here is 1. If you notice, both of these sides of the expression, the left and the right side, have the same base. This tells us that their exponents are equal to each other. So we can go ahead and say that x is equal to 1. This tells us further that ln of e is equal to 1. So this one right here represents the value for this whole expression. Now let's have another example. So we're supposed to evaluate this expression ln of 1. So that we can evaluate this expression right here, we are going to equal this whole expression with a variable, let's say y. Now, please remember that this ln expression has an invisible base of e, so that we can go ahead and say that e raised to the power y is 1 is its equivalent exponential form. Now, we remember that if the exponent of any base is 0, the value is 1. So that we can go ahead and say that there is an invisible exponent here that is 0. 1 raised to the power 0 is just 1. So that we can go ahead and say that y is equal to 0. And this makes sense because if we have e to the power 0 is 1. So 1 raised to the power 0 is also 1. So our y value is 0. So that means ln of 1 is always 0. Now let's have another example. To evaluate this given expression right here, we are going to equal this whole thing into a variable, let's say x. Again, we remember that there is an invisible e base for this, so we can go ahead and change this to its exponential form. That would be e raised to the power x is equal to square root of e. So I'm going to go ahead and write it down here. Now we remember that this e has an invisible exponent of 1 and the index here is 2, so that we can rewrite this square root of e to its fractional exponent form. Now, if you notice, both sides have the same base, which is e. So if the two bases are the same, we remember that their exponents are equal. That tells us that our x value is 1/2. We can also solve this problem a different way by using the property that ln of e is equal to 1. So that we can go ahead and rewrite this expression up here as... So what I did was I changed this square root of e to its fractional exponent form. That is e raised to the power 1/2. Now, using the power property of logarithm, this power or exponent right here can be written in front of the ln so that this comes out. Now, we remember that ln e is equal to 1. So then we have 1/2 times 1 is equal to x. 1/2 times 1 is 1/2. So our x is 1/2, which is the same thing as the first method that we have up there. So this means that ln of square root of e is equal to 1/2. Now let's have another example. To solve this expression, ln of the cube root of e, we will equal this to a variable, let's say y, so that we can go ahead and say that there is an invisible base of e right here. So that would be e raised to the power y is equal to the cube root of e. So I'm going to go ahead and write that up here. Now, this cube root of e can be written in exponential form as e raised to the power 1/3 because there is an invisible 1 right here. So that we can go ahead and write that down here. If you notice, their bases are the same, so that we can go ahead and say that their exponents are also equal to each other. That tells us that our y is 1/3. This tells us that this whole expression that we have here is equal to 1/3. We can also use the power property of logarithm to solve for this expression. So this expression that we have right here can be written as ln of e raised to the power 1/3, because that's a cube root, so exponential form will be 1/3, and that is equal to y. Now we remember that using the power property of logarithm, this 1/3 can go to the front, so this comes out. Now we remember that ln e is equal to 1, so let's go ahead and solve for y. If you notice, both methods are the same. This tells us that this whole expression is equal to 1/3. So that is how we evaluate natural logarithmic expressions.